All right, we're going to work on the derivative graphs, and what we're trying to do is sketch something that looks roughly like the derivative of these functions here. So when I do stuff like this, what I want to do is I want to kind of figure out some things that I know for sure. So anytime we have a place like this where the tangent line is horizontal, I know that at that spot I'll have my derivative will be 0. So I go ahead and anywhere that I have a tangent, horizontal tangent, I'm going to make those spots 0. So the derivative is going to go through these 3 dots here. I know that for sure. Then the other thing I know is that when this graph is increasing, all of these derivatives are positive. Okay? And we'll talk more about where the maximum derivative might be located and how we might know that. But I know that all of these are positive values, and they start to approach and get closer and closer to 0. So I'm coming from a positive place here and hitting 0. Okay? Then after I hit 0, my derivatives start to become negative, right? So they come down and they're negative for a while, and then they turn and they become positive again after here. Now I have positive slopes. Now I'm positive until around here, and then I'm back to negative, and then from there on I'm negative after that. Okay? Now, how tall are these? We don't know, right? That's not so important. What's important to me would be the general shape, that you have it positive when this function was increasing, 0 when we were at the horizontal tangent, negative when the function is decreasing. That's what I should see in your derivative graph. Okay? For this one here, our derivative is a constant down 1 over 1. It's got a constant -1 to it. Actually, it scales off a little bit. It's a -1/2. So really, I'm going to come in at -1/2. It's a constant all the way until here. And then it starts to go up 1 over 2. It's a constant 1/2 after that. So we get a graph that kind of looks like that. That would be our derivative there. For number 3, we just have a horizontal line. So the slope of that's always 0. So you should have a 0 line right on the x-axis here. For this one, here's our horizontal tangent. So I'll put my dot right there. Okay, before that, we were close to 0. Then we got a little bit bigger, but they were always positive, and then positive, and then all of a sudden we were getting close to 0 again. So we should have something that looks kind of like this, growing and then not growing so much and coming in here like that. Again, where we hit the top of this, we'll talk more about next chapter. For back here, though, now all of these are negative, and we get negative, negative, and then all of a sudden it starts to go back towards 0. So we should have something that kind of looks like that. Again, kind of roughly. We're not going to worry so much about where exactly do these things turn, but I want to see it positive on this side, negative on that side. For this one here, we have a constant slope again. This time it looks like it's going up, no, maybe 1/2 or something like that. But it's a constant, so you should have a constant positive line, something like that. I would think would work really well. And then this one's all goofy, right? And so again, put your, wherever you see is horizontal tangent, put a 0. Horizontal tangent, let's put a 0. Horizontal tangent, let's put a 0. Okay? Before this horizontal tangent, our slopes were positive, so we should be coming in from the positive. After that, our slopes are positive, right? Up until this one here. So we come in, we kind of just bounce off the x-axis there. We do a little curve like this, a little hump. We're positive in here because that's where the graph is increasing. Then from here to here, the graph is decreasing. So now our slopes are negative, our derivatives are negative. They come back to 0, and now they're positive. In fact, they're heading way off into the positive infinity. So we should have our derivatives heading off to positive infinity. And then after that, our slopes are negative, but they're approaching a flat. They're approaching horizontal. So they're coming from the negative and approaching 0, something like that. So this would be a good derivative graph. Again, zeros are important. Positive when the function was increasing, negative when it was decreasing. That's what we would be looking for.